Welcome, everyone. For today's prep, we're going to see how to computationally find the intervals of increase-decrease for a function f using its first derivative f prime. And the major result that we're going to use is this one right here. So let's read through it. So suppose that we're looking at an interval from a to b. So you want to think of this is like a section of the x-axis. Well, what this says is that if the derivative is greater than 0, then the original function f is increasing. And if the derivative is less than 0, well, then the original function is decreasing. So if our first derivative is positive on an interval, the original function f is moving up. It's increasing there. And if f prime is negative, well, then the original function is moving down. It's decreasing. So this is what we're going to be looking for. We're going to be trying to figure out where is f prime positive or negative. And really we want to know where does it switch signs? How can it switch from positive to negative? And it can switch in one of two places. And we call these places critical numbers. So x equals c is called a critical number of the function f, provided one of two things happens. Either the first derivative is equal to 0 there, or the first derivative is undefined there. So these places, these are where the function f prime, where f prime can change signs. So these are the only possible locations where f prime could switch signs. And probably should say the only possible locations. So this is the only way f prime can switch signs. Either it crosses the x-axis or it kind of jumps over the x-axis. That's what happens with this undefined. So, and we'll see later on, these critical numbers, well, they're kind of important, so that's why we give them the name critical number. These also turn out to be the only possible locations where the original function f has a max or a min. So a lot's going to happen at these places. So we'll see that later on. But these critical numbers, these x values where either the derivative is 0 or undefined, for us right now, these are important because they're the only possible locations where f prime can go from positive to negative or vice versa. And later on we'll see, well, these are also the only possible locations where the original function f can have a max or a min. So we're going to be talking about these critical numbers a bit. And so the steps for finding intervals of increase-decrease, the first step is to calculate, well, the first derivative. The second step is to calculate the first derivative, or to take that derivative we just calculated, set it equal to 0 and solve for x, and then also figure out where that first derivative is undefined. And then from there, we're going to create a sign chart for f prime, and then kind of fill it in, and that'll tell us where f is increasing, decreasing. So I want to jump down and try out example 2. And we'll do example 1 either after this or we'll save it for class. So let's look at example 2. So we want to find the intervals of increase and the intervals of decrease for this function f. And the function here is 1/3 x cubed minus 2x squared plus 3x plus 1. All right, so let's go through the steps here. So we want to figure this out. So first step, we need to calculate f prime. All right, so we got to get f prime involved here. So let's differentiate. So when we differentiate this first term, we bring the 3 down. It'll multiply it with the 1/3, so that'll just kind of multiply to 1. So the derivative of that first term is just x squared. Derivative of the second term is just minus 4x, and then derivative of the rest there is just plus 3. All right, so this is what we get for our first derivative. Now, as soon as we have our first derivative, it's usually a good idea try to factor it right away, because we're going to use that factoring. So in this case, it factors nicely into x minus 1 times x minus 3. So negative 1 times negative 3 multiply together to give us positive 3, and then negative 1 and negative 3 add together to give us negative 4. So it factors nicely. So this is a good thing to do if you can do it right away. All right, so now what's the second step? The second step is we actually want to find those critical numbers. All right, so this is where f prime could be equal to 0, or f prime does not exist. So f prime not existing, this usually happens when we have division by 0. So there's no division here. It's just all multiplication and subtraction. There's no division, so we're not going to get anything with that one. So no x value there. But let's look at the derivative equal to 0. This is where a lot of our functions we're going to see things. So let's take our factored version. We'll set that factored version equal to 0. And then once we have it all nice and factored, well, rather than trying to look at this whole thing, we can just set each of the individual factors equal to 0, and then keep solving those. So x minus 1 equal to 0, x minus 3 equal to 0. So we get kind of two easier equations to solve, and then we can just kind of finish solving those. So in this case, we get x equals 1 and x equals 3. And these are the critical numbers. Okay. So once we have those, then we're going to set up our sign chart for f prime. So the way this works is we're going to start by drawing kind of like the x-axis. So let's get our x-axis drawn here. And it goes from minus infinity to plus infinity. So we're kind of drawing the whole thing. And what we're going to do is we're going to start by plotting these critical numbers on this number line. So x equals 1, x equals 3. So let's get those plotted. Okay, so what these critical numbers do is they really split up our x-axis into 3 regions, 3 intervals. So the first interval goes from minus infinity to 1. The second interval goes from 1 to 3. And then the third interval here goes from 3 to infinity. So those critical numbers kind of split up the x-axis for us. Okay. So, and we're using these intervals, we're using parentheses because we're thinking of these as open intervals. All right, so what we want to do is we ultimately want to figure out the sign of f prime on each of these intervals. So we want to know, is f prime positive or negative on that first interval? And the way we're going to do this is we're going to, again, go back up to the factored version, and we're going to use every single factor that we have here. We have to use every piece. So we're going to list the x minus 1 factor, then the x minus 3 factor. And the idea here is we're going to figure out for each of these individual factors the sign, and then kind of put it all together. So let's see what we mean. So let's look at this x minus 1 factor, and let's test this first interval. So we want to know, is this going to be positive or negative? And the way we can do this is with a test number. So for this first interval, what would be a good test number for that first interval? We want something that's less than 1. So 0 would be a good test number. So if we plug 0 into this piece, we get 0 minus 1, we get a negative. So all we're going to do is just keep track. We get a negative there. Then, on the next factor, we're going to plug in the same test number. So we could use 0. You could use anything, though, that's less than 1. You could use negative 10 if you want. But 0 is always nice and easy. Plug it in. We get 0 minus 3. We get another negative. So what happens here is on this interval, what we end up with is a negative number times a negative number. So it's a double negative. So that means f prime is positive. And by our test, by our main result here, when f prime is positive, that means the original function is increasing. So on this first interval, our function is increasing. All right, and the idea is then we go and do this for all the other intervals. So now let's look at the middle one here. So a test number for that, we want something in between 1 and 3, so 2 would work nicely. So our test number there will be t equals 2. And again, we just go and plug it in. So plug it into this factor. We get 2 minus 1, which is 1. So positive. We plug it into this factor. We get 2 minus 3, which is negative. And then in this case, if we go back up to our factoring, all of these factors make up f prime. So we have a positive number times a negative number, and the result of that is negative. So when f prime is negative, that means the original function is decreasing. So f prime is negative on that interval, which means the original function is decreasing. All right, so we got one more interval to check. So, again, we're looking at the interval 3 to infinity, so we just want a number that's bigger than 3. So, keep it easy. 4 is perfectly good, so let's use 4. But you could use 10 if you want, or, anything like that. Just something bigger than 3. And we're just going to take this test number, and again, we're going to plug it into each of the factors. So when we plug it into x minus 1, we get 4 minus 1 is 3, so it's positive. And then when we plug that into the x minus 3 factor, we get 4 minus 3, so again, positive. And what we have then, if we go back up to our factoring, we end up with a positive term times a positive term. So 2 positives getting multiplied together, the result is positive. And what that means is f prime is positive on that last interval. So that means our original function is increasing there. So we have our intervals of increase, decrease. We've filled in the sign chart. So that was the fourth step, just kind of getting this all filled in. And now we can state our intervals. So f, the original function. So it's just kind of important to keep this in mind. We're figuring out the sign of f prime. So we know where f prime is positive or negative. And what this is doing, this is telling us about the original function. So the original function here was this one right here. So we know where this function is increasing, decreasing, where it's moving up, where it's moving down. So moving up, we know this function is increasing on the interval minus infinity to 1 and from 3 to infinity. We're doing open intervals, so the parentheses. And then we know f is decreasing on that middle interval. All right. And that's the idea. Finding the intervals of increase, decrease for a function using its first derivative. So we're going to try a few more of these in class. And I think we'll save it for class. But we'll look at example 1. Example 1 is maybe a little trickier, I think, just because we're not given the original function, but we're given its first derivative. So there's kind of less work here that we have to do. But we'll kind of go through that process again. So we'll try a couple more of these in class. So we'll see you then. Bye-bye.